In listen-only mode.
Hey, good morning, guys. Thanks for joining our webinar this morning on the topic of why do you need a compliant electrical safety program. Our presenter today is Terry Becker from PwC Consulting, Calgary, Alberta. Is it right, Terry? I'm sorry, I missed it. So Terry will present this webinar. It will be about a 45 minutes long duration. There'll be a few polling questions in between. And also, we strongly recommend you to type in your questions as you go through the webinar, and we'll definitely answer them at the end as time permits. Without any further delay, I will turn it over to Terry. Terry, it's all yours. Go ahead.
Thanks, Banu. So good morning, everybody, and thanks for joining this webinar today. Just some background information on myself. I'm based out of Calgary, Alberta. I'm an electrical engineer and 29 years experience in that effort of my career, but I've been devoting the last 13 years of my career 100% to electrical safety. As we go through this webinar, you'll probably get the idea that I'm quite passionate about the topic of electrical safety, arc flash and shock hazard. So for the last 13 years, that's all I've been doing. And my mission has been to, ultimately save lives or reduce risk related to arc flash and shock hazards. More background information. I'm a founding member and the first past vice chair of the CSA Z462 Workplace Electrical Safety Tech Committee. I'm currently a voting member, and I'm the Clause 4.1 and Annexes Working Group leader. I'm also a founding and voting member of the CSA Z463 Maintenance of Electrical System Standard for Canada. If you're in the States and we're not aware, we have an equivalent standard to NFPA 70B. I'm also a voting member on the IEEE 1584, a guide for performing arc flash hazard calculations technical committee. And I've attended all NFPA 70E tech committee meetings since 2007 as a guest. So I've been intimately aware of what's been happening with NFPA 70E as it's transitioned through its addition since I initially got involved with arc flash and shock, which was back in 2005 and 2006. I'm also and have been a keynote speaker and presenter at conferences related to obviously arc flash and shock and electrical safety in Canada, the United States, Australia, and I presented in India, in fact. I'm the founder of and creator of ESPS Electrical Safety Program Solutions, Inc. back in 2007, and I currently have my own new company, TW Becker Electrical Safety Consulting, Inc., and provide electrical safety consulting services, electrical safety program development, external electrical safety audits, and arc flash and training services. I'm a pioneer in electrical safety in Canada, and I use those words because back in 2005 and 6 in Canada, we did not have any direction with respect to arc flash and shock at all. So here's our agenda plan for today, just a brief introduction of myself, which I've accomplished. The go-to webinar control panel. As I go through the slides, please enter questions in the chat feature, and we'll answer questions at the end of the webinar. As I go through the material, I won't be answering questions, but please, if you do have a question and you want to save it, put in the chat window. We'll try and address as many of those questions as we can at the end of the webinar. I'll be here and online for as long as you want me to be. So if there's lots of questions, I'll stay online and answer them all, well, to a certain amount of time. What we're going to cover today is there's going to be some poll questions. So right away, I want some interaction. I want some feedback. I sort of want to, use that feedback as I go through the webinar, and then hopefully you can use those questions to gauge and really interpret the information I'm presenting. I really would like you to do a gap analysis / audit in real time as I go through the information and talk about why you need a compliant electrical safety program. So there'll be some poll questions along the way. What I'm going to cover off is some of the legal requirements, the occupational health and safety regulatory requirements for US and Canada. So I'm assuming we have Canadian and US participants today. And so I'm going to cover both countries off with respect to this discussion of why you need a compliant electrical safety program. And then we'll address some of the other information related to that why statement, electrical incident statistics, briefly review that and give you some information there, and maybe give you some information you're not aware of that you can use and build up in your resources, your library of supporting information related to arc flash and shock hazards, and again, your electrical safety program. Talk about safe installations and its relationship to this discussion. And then specifically occupational health and safety management system standards. There's standards for building safety management systems that you can use to build your electrical safety program. Due diligence defined very briefly, those are words that are subject to interpretation by an employer. And then the role of NFPA 70E and CSA Z462, and then wrap that all up at the end with why you need a compliant electrical safety program. And like I said, poll questions along the way. And at the end of the webinar, we'll open the mic for additional questions. So please enter them in the chat feature in the go-to webinar menu. So poll question 1, do you currently have an electrical safety program, yes or no? So the poll question will come up on the screen. We're going to allow everybody 10 to 15 seconds to answer that question. Do you have an electrical safety program right now in your organization, yes or no? So again, we'll just hold this poll open for 10 to 15 seconds. Really appreciate your participation in answering these questions. It'll be part of how I can present the information and hopefully get a better understanding. So just waiting for responses. And there's the response. 77% say yes, you do, and 23% say no. Okay, that's interesting. So we'll keep that in mind. The next poll question. So 77% of you say you have an electrical safety program. The next poll question is, have you completed an internal electrical safety audit of your company's electrical safety program? Yes or no? So for the 77% of you that said you had a program, have you completed a formal internal electrical safety audit? So this is formalized, right? Validation and verification techniques used, generate a report, corrective actions, internal electrical safety audit. And I recommend this is done every 12 months, once a year. 70E and Z462 provide guidance on this, which we'll review later as well. So I'm just waiting for a response here, 10 to 15 seconds. Have you completed an internal electrical safety audit of your company's electrical safety program? Yes or no? So 35%, right? So this is a telling story, and I'm not surprised, actually. In my experience providing electrical safety consulting services, I find that this is a significant gap, and it is a key requirement of NFPA 70 and Z462 explicitly, as well as other requirements related to occupational health and safety standards. All right, one more polling question. If you have an electrical safety program, do you believe it's compliant? So that's a bit of a loaded question, and as we go through the webinar, I'm hoping that you'll be able to get some more information to gauge the answer to this question. But right now, do you believe it's compliant? Right, with your understanding of what you believe compliancy would mean, and then we'll go through the webinar, and hopefully you'll come out the other end going, geez, Terry's right, we don't necessarily have what I understood would be compliant. So I'm just waiting for the results to come in. So if of those of you that have a program, do you believe it's compliant? And we're just waiting for the results. So 68% believe that your program's compliant. So keep that in mind as we review the webinar PowerPoints, and then your gauge of how you felt you were compliant. So that's interesting, 68% compliant. All right, so legal requirements. So again, legal requirements relate to the occupational health and safety regulations, and specifically I've summarized some of those requirements for OSHA, and in Canada, occupational health and safety regulations provincially or territorially or federally. So there's an obligation to identify, in this case, I'm talking specifically to electrical hazards, but all workplace hazards. So arc, flash, and shock should be identified, and you have to advise your workers when they'll be exposed. So you have to communicate those hazards, and then you have to work with your employees to protect them. And the government would want you to eliminate exposure as a priority. And if you can't eliminate exposure to those identified hazards, you have to reduce risk to as low as reasonably practicable, applying the hierarchy of risk control methods. And I've got that inverted pyramid on the bottom. There's 6 hierarchy of risk control methods. And depending on the regulator, they may provide specific direction on those risk control methods, and it may not include all 6. within the legislation. So it's up to the employer to due diligence, which we'll talk about later, decide what to do if you cannot eliminate exposure. You'll find that the regulations also provide specific direction related to personal protective equipment. They'll also have some information on training. The one thing that is very clear in the OHS regulations from a legal requirement is the control of hazardous energy lockout, tagout. And then I've just indicated individual group lockouts. So the legislation is pretty clear with OSHA in the States and occupational health and safety regulations in Canada, federally and or provincially and territorially. So it's a bit different as far as the jurisdiction, completely federal, and then states can have and will have additional regulations in place above and beyond OSHA. In Canada, really the provinces and territories set the OHS regulations for most industries, commercial, industrial, or institutional. So I'm going to divide this up into US and Canada. So just briefly, and I'm not going to go into the details, but I want to highlight again, and get to the why you need a compliant electrical safety program. So there's a general duty clause that's within these regulations for the hazard ID component and the application of risk control methods. And then I've just listed some of the specific regulations in the CFR 1910, subpart I, J, R, S, and K. So there is specific legislation in the US related to, again, PPE, control of hazardous energy, special industries, utilities, generation, transmission, and distribution. The entire subpart S is where we more explicitly get into some direction from OSHA, where NFPA 70 would come into play, and then subpart K under 1926 for construction. So again, the regulations are there, but overriding all of that, there is the need to identify workplace hazards, eliminate exposure, and implement some controls. Again, practicable is another one of those legal words. So it's a subjective interpretation of your due diligence related to these regulations. So remember, I'm trying to build up the case of why you need a compliant electrical safety program. So there's just another slide with some of the specifics. And again, I'm not going to go into detail. Again, you will be provided access to this webinar offline, and you can review this information in more detail. But explicitly, there is some very unique and prescriptive information in OHSA's regulations related to electrical safety in the arc flash and shock hazards. Interesting enough, with respect to OSHA, so some additional information you may not be aware of. OSHA does provide recommendations for an employer to develop an occupational health and safety program. And the link is on the bottom to get to this guide. So that's the website, recommended practice for safety and health programs. And then they have that PDF document, which is an amazing document. As far as your auditing component of your electrical safety program in the US, this would be a great website and a great document to use to say, do we have this information covered off in our electrical safety program to gauge if it's compliant? So if you dig around, there's lots of information out there. The regulator in the US and in Canada, because in Canada, and I'll get there, the provinces and territories provide guidelines, and there's a separate certificate of recognition system, which we'll talk about. And the US has a similar process where the regulator wants you to develop an occupational health and safety management system, and they give you guidance on the content that should be in it. So if you're not aware of this website and that particular document, it's on the web, that's the link. And you could use this as part of your the information you use to audit your electrical safety program to, again, make sure it's compliant. Again, look to the regulator for guidance. They do provide some support. In this case, that document is amazing. It is amazing. Separately in the US, there's a voluntary protection program. So this is something else that OSHA has in place. And if you commit to this and do go through with it, what they're trying to encourage is that if you develop a safety management system and you ensure that it's audited and that it's working, and they anticipate that you'll have lower injury and illness rates, you'll lower your workers' compensation premium costs, and you're partnering with OSHA. So there's another sort of, partnering with the regulator. Should we partner with the regulator? I would want to partner with the regulator if they're offering an opportunity to. So this is another aspect of your overall safety management system, because your electrical safety program would be underneath your company's overall occupational health and safety management system. So another piece of information, depending on your organization, if you're participating in the voluntary protection program in the US with OSHA, if you're not, something to look at with your safety department. If you are an electrical engineer, a technologist, or an electrician on this webinar right now, or we might have some safety professionals as well, and some other management roles as well. So there is opportunities here to do a far superior job. Partnering with the regulator, I think, is a good plan. And again, there's side benefits here, which is workers' compensation premium lowering your workers' compensation premium costs. And this whole partnering with OSHA, right? Safety ambassadors, they're trying to promote, again, that end, which is, again, hopefully zero harm on the work site. But if we can't get zero, then we apply the controls and reduce risk to as low as reasonably practical. So there's a link there to that as well. In Canada, it's a little bit different. So we have federal regulations that would only apply to federally owned buildings and facilities or organizations. And where we do have organizations that cross provincial territorial borders, like pipelines, they would be federally regulated. So it's not, most of the organizations in Canada, employers, are regulated provincially. So again, the standard general duty clause, what I show you on the screen is Canada Labour Code Part 2, the sections that discuss the general duty clause and do provide specific information that the employer needs to address, again, work that's completed on electrical equipment. There is a separate electrical safety section itself. It's a bit outdated though, and it focuses more on utilities. So again, just a general summary, employer-employee requirements are outlined. Control of hazardous energy is well documented within these regulations, and PPE requirements, overhead power lines, and limits of approach. So, and that's another issue, is the limits of approach are legal approach boundaries in both Canada and the US under regulations. So provincially and territorially in Canada, it gets a little more specific. In fact, a lot more specific and a lot more granular. The overriding general duty clause is there, but the provinces and territories within their regulations will have more detailed information on electrical hazard identification, risk assessment, application of controls. They'll be far more specific to unique industries as well, consistent with federal regulations, employer-employee requirements, control of hazardous energy, personal protective equipment, overhead power lines, limits of approach. But there are now specific electrical safety requirements. So province to province or territory, the electrical safety content will be minimal, or it could be quite significant. So in British Columbia, they have quite significant electrical safety content. In Manitoba, they have, again, very significant content in their legislation related to electrical safety. Ontario has far less. And so again, depending on the province or territory, you have to really understand the difference. And if you have your organizations in multiple jurisdictions, you've got to be aware of any of the unique requirements within the legislation. Interesting enough, the Minister of Labour in Ontario has done several electrical safety blitzes over the last probably 10 years and put specific focus with those blitzes on arc flash and shock hazards. And the Electrical Safety Authority in Ontario is the jurisdiction having authority for the Ontario Electrical Safety Code, has also put specific focus on electrical safety. So again, in Canada, provincial or territorially managed, and you need to pay more attention because these regulations are a lot more prescriptive and detailed. So poll question number 4, have you had an electrical incident in your company, yes or no? Have you had an electrical incident and in your current employment at the company you work for now, yes or no? So we'll allow 10 to 15 seconds here again for the response. Have you had an electrical incident in your company, yes or no? All right, I'm just waiting for a response. I'll bring up that response. 37% say no. That's good information. Sorry, 63% say no. That's good information. 37% say yes. So again, that's interesting though still. 40% of the attendees say you've had an electrical incident. Was the electrical incident a shock and or electrocution, a burn injury from arc flash, or have you had both electrical incidents of the respondents that said you have had an electrical incident? So I think it was 37% said you did have an electrical incident. So we'll bring up this poll question. Okay, and actually, it's going to segregate it to shock and or burn injury from arc flash. So again, I wanted it to be shock, arc flash, or both, but choose the one that you've had the most injuries, the most incidents: shock, electrocution, or arc flash. So again, the responses here might be skewed a little bit. I wanted to have the poll say shock, electrocution, arc flash. So shock and electrocution, 70% of the incidents of the respondents. So that's probably true, because when I talk about electrical incidents statistics coming up in the webinar, the stats that we have from the reports from governments or other agencies would support that. But both hazards we do have incidents for both hazards in the workplace. It's a given. So the next slide is electrical incident statistics in the US. So this report is probably the best report that I've been able to find, put together by NFPA and UL under the Fire Protection Research Foundation. And that's a link. This is a publicly available report published in 2015. So if you're not aware of it, I would recommend you get it and download it and put it again in your resource toolbox for your management of your electrical safety program. So we had confirmation with the poll that electrical incidents are occurring. The poll confirmed and aligned with the statistics that shock has a higher frequency, arc flashes are less frequent. This report had one piece of information that they collected where they had 20 years of data, and there was 5,000 fatalities related to electrical incidents. And really that was one shock and electrocution a day in the United States. And it was one arc flash fatality where the worker didn't survive the burn injury every 3 to 6 months. So there might be 2 to 4 arc flash burn injuries in the US a year. And again, unfortunately, one electrocution, a shock that led to an electrocution every day in the States. And I would believe that those statistics are still valid. And I've attended the IEEE Electrical Safety Workshop, and there has been papers on incidents, and the trend has come down. But what's interesting, it seems to have flattened on the electrocutions, which are mostly related to overhead power lines. And I just don't know why we can't seem to solve that problem. All right, so all worker roles are impacted, all industries are impacted. It's construction, operating facilities, and then maintenance activities. And this report breaks it down with some really good information, some really good graphs. So again, I'm outlining again, why you need a compliant electrical safety program. We're having incidents still, and obviously there's lots of work that still needs to be done. In Canada, electrical incident statistics are available provincially. I've just given 2 examples on the screen. They're not as detailed as that NFPA report. Again, we're looking at a report in the US that we can use in Canada when we're looking at at that incident frequency and where the industries are having the incidents. But we do have reports here. They will not necessarily break it down as in much detail as an NFPA report. So again, the one from Alberta was from 2017. Now these are lagging as well. You can't get this information in real time. So there'll be a lag at least a year, right, if not more. So I've given an example on the screen of Alberta, again, publicly available. The Electrical Safety Authority in Canada has the most detailed reports. They would mimic pretty well the NFPA report that I showed on the previous screen. So, and then what's happening is we are seeing arc flashes start to show up where they previously wouldn't be included. I think historically, if there was an arc flash, it might have been reported as a fire in an electrical room. But now we're seeing clarity on the incident statistics being collected by the government in Canada, at least probably in the States, that it's a burn injury related to arc flash. So we're starting to have it show up and it says arc flash, right, in the reports rather than a fire, right? So that's good. We need this clarity. The incidents are happening, shocks and arc flash. Again, shocks more frequent, overhead power lines, again, highest frequency of electrocutions. Arc flash incidents are recorded in Canada now. We're starting to see them show up in these reports. And as I said, it's just not as detailed, this information in Canada. And again, provincially or territorially available. So safe installations and its role. So we have obviously 2 different codes, the National Electrical Code NFPA 70 in the US and the Canadian Electrical Code C22.1, the C Code Part 1 in Canada. So I bring this up because these are legal requirements. They're a prerequisite to the normal operating condition defined in NFPA 70E and CSA Z462. So we need to understand if we have safe installations. Your electrical safety program should include content that says that you will ensure that you have safe installations, and you should have considered this when you completed your risk assessment procedure for work tasks. So electrical incident reporting as well, I find that some companies don't know that the jurisdiction for these codes requires electrical incidents to be reported. So it's usually an electrical fire, an electrical injury, death to livestock. Again, the jurisdiction, and again, depending on the state in the US, this may not be consistent across all states. But in Canada, it is a legal requirement that if you have an electrical incident, you not only report it out if there's injury to a worker, but to the jurisdiction having authority for the Canadian Electrical Code. What they're looking for is non-compliance to the code caused the incident, or potentially electrical equipment failures that are systemic, and then they communicate this information across, across Canada to the US. So again, safe installations is a requirement, and your electrical safety program needs to consider it. It's a separate requirement, obviously, with respect to construction permits and operating permits and hiring, again, qualified contractors with journal electricians and the like to get the work completed. Occupational health and safety management system standards. So, so far I've outlined a whole bunch of information, and like I said, I'll roll it up here as we move to sort of summarizing, why you need a compliant electrical safety program and how you gauge that compliance. That's the key. When you do your gap analysis or audit, you have to have sort of a validation verification. What are we gauging that compliance against? So the content in your electrical safety program, these standards provide a framework, right? Or what you may want in your table of contents, similar to that OSHA document that I showed you. And in Canada, what I forgot to mention is in Canada, we have the Certificate of Recognition system. So the provinces and territories encourage employers to develop and audit occupational health and safety management systems, and then you will get a workers' compensation premium reduction. Safety pays in the government's eyes, but they're trying to encourage and also in the case of some of those regulations, legal requirements for having an occupational health and safety management system within those OHS regulations. So as far as gauging compliance of your electrical safety program, you can use ANSI Z10 and CSA Z46001, these occupational health and safety management system standards, to say, do we have the appropriate content in our electrical safety program and the related appendices and any forms and flow charts and other information that we've developed and that we use in our electrical safety program. So both these documents promote a plan, do, check, act philosophy, which is something that I have used in my consultancy since the beginning, and we'll review that as well as we go forward in this webinar. So then these documents, and this is just a quick summary, this isn't necessarily all the detail, that your electrical safety program should have something about policy and management leadership, worker participation, hazard identification, risk assessment and the hierarchy of risk control methods, education, training, and competency of workers. There's a difference between qualification and competency. Again, they're two different things. Incident management, emergency response plan, monitoring, measurement, and assessment, and that's in real time. And then audits at a more regular frequency, annually or every 3 years, and then document and record retention. So these documents can be used to gauge how you determine if your electrical safety program, the content, is compliant. So here's the plan, do, check, act philosophy. So I just wanted to put specific focus on this because this is, again, another tool that you can use. So your plan is, do we have a program that's compliant to the regulations? Does it cover everything off? We developed that program, so we the do of the plan, do, check, act is develop the program so that we have documentation to support policies, practices, and procedural requirements related to complying with the legal requirements of the OHS regulations. Then the check is real-time monitoring, performance, and audit. And then acting is following up with corrective actions and updates to your electrical safety program. So right now would be a good time to open up your electrical safety program. And if you haven't done an audit, do one now, because NFPA 70E published its 2021 edition in September, and CSA Z462 will publish its next edition at the end of January 2021. So the standards have changed. That's a reason why you want to audit your program, to make sure it's compliant to the latest requirements of the standards, which I'll review coming up. So this is just a graphic again with the plan. So we plan to the regulatory, legal, and other requirements, hazard ID, risk assessment, set objectives and targets. We benchmark our competitors in industry, and we use industry standards. And we develop, again, this electrical safety program. So develop and implement the electrical safety program, communication awareness, preventive and protective hierarchy of risk control methods defined and deployed, competency and training, incident reporting, emergency response, preparedness, contractor management, management of change, a whole other topic. I find that electrical safety programs do not address management of change. So there's another opportunity to enhance your electrical safety program by ensuring you address management of change within the program for critical requirements such as electrical protective device changes or the document itself, and follow a formal MLC process. Checking is the real-time monitoring, key performance indicators as you go. How many energized electrical work permits did we have this year? How many energized electrical job safety planning forms were filled out this month, right? And it gives you, again, measurement tool in real time, and then auditing those permits and auditing those energized electrical job safety planning forms every month to make sure that they're being completed correctly by qualified electrical workers and task qualified workers. And then we get to the more formal audits. So internal electrical safety audit, a supervisory level audit is every minute, every hour, every day, every week. The supervisor is doing real-time audits as part of their job role. And then acting, again, is management and safety, health, safety, environment, and supervisor review. Budget allocation, another ongoing endeavor that your electrical safety program has to address. You have to have budget for updating PPE, for ongoing training, for updating your electrical safety program. And more specifically, where you need more funding is for arc flash hazard incident analysis studies. So if you have a compliant electrical safety program, it's going to help with the budgeting. It'll help justify the ongoing need for budget dollars to be made available, and help you with getting that budget from your management. So due diligence, and what I did is a little different approach here. I've got a definition of due diligence that just from Google. So due diligence is important as a legal defense for a person charged under occupational health and safety legislation. In other words, the defendant must be able to prove that all precautions reasonable under the circumstances were taken to protect the health and safety of workers. And then I've got ensuring that you don't have, so this is what you need to make sure you don't have. You don't have lack of knowledge. You don't have lack of a written occupational health and safety management system, or in this case, an electrical safety program that works complementary with your overall occupational health and safety management system. You don't have lack of employee training. You don't have lack of effort to prevent injury, and you don't have lack of enforcement of rules. So there's another requirement. If you have an electrical safety program, the policies, practices, and procedural requirements have to be enforced. It's the other end of this. We want it all to be positive, but at the end of the day, if you have a compliant electrical safety program, it has the appropriate policies, practices, and procedural requirements in it. It gives the supervisor the tool they need to ensure enforcement, right, of those, again, policies, practices, and procedural requirements. So due diligence is subjective from one company to the next. Everybody that said they have electrical safety programs, they're probably going to be all different. They will be. And hopefully in this webinar, I'm in a short period of time highlighting where you can go to get additional information to, again, do a gap analysis or a formal audit to gauge how you determine if it's compliant. And ultimately, we need this due diligence in place. And you need to be able to defend with respect to arc flash and shock hazards if you ever have an electrical incident, which many of you said you have had an electrical incident in the poll question. You'll need to be able to stand up to the test. And I think what's also happening right now is companies aren't being tested. And that's a good thing that we're not having maybe a higher frequency of electrical incidents, but the real test of your due diligence will be related to the severity of the injury and, heaven forbid, a fatality, right? A shock leading to electrocution, or an arc flash burn injury leading to, again, a fatality. So subjective, what due diligence is, and your electrical safety program compliance will ensure, one, that we try to drive to zero incidents. That's the goal, zero harm, zero incidents. But if we ever have one, that we can make sure that as the employer, right, we did everything that was reasonably practicable to try and not have that incident. Something else, and the incident investigation would come out on why that happened, why the incident occurred. So to wrap everything up that I discussed so far is this flowchart, electrical safety due diligence framework. And I've promoted this since the beginning. Right? You know, when I got educated about this, when I was working as a staff electrical engineer for a large employer before I became an independent electrical safety consultant. The company I worked for, we were all immersed in the role I was in anyways as an electrical engineer in our ongoing operations and maintenance of our organization. So I knew about the regulations, but I didn't know at the time the depth of what the due diligence requirement was. So really those regulations are at the top. The general duty clause, again, all hazards identified. The employer has an obligation to eliminate exposure or reduce risk, and the hierarchy of risk control methods, the 6 of them. And then how we can achieve this requirement is through the Occupational Health and Safety Management System, again, with a certain framework based on those standards, ANSI Z10 and Z45001, or OSHA's requirements, or in Canada, certificate of recognition. Underneath that overall safety management system is your electrical safety program, the Plan, Do, Check, Act philosophy, and we want to use standards now. So this is where we're going to go, is we're going to talk about the standards, NFPA 70E and CSA Z462, that give us the tools we need within our electrical safety program. 70E and Z462 are not electrical safety programs. I call them toolboxes, and they give us the tools we need to define specific policies, practices, and procedural requirements within our electrical safety program. And then that program has to have a compliant framework, content. And again, Terry, I got 10 pages. Is it enough? Terry, I got 150 pages. Is it enough information in my electrical safety program? There's not an easy answer to that. It's all relative. So again, 10 pages, 20 pages, 100 pages. If you believe it's adequate due diligence and you believe it's compliant, then that's what you would decide for your company. All right. So this is, again, electrical safety due diligence framework, how everything comes together. Now, another poll question. Have you completed individual work task risk assessments using a defined electrical hazard risk assessment matrix and related risk register table? Now, that's a loaded question, but it's a valid question because NFPA 70 and Z462 have a mandatory risk assessment procedure requirement. So on the right-hand side, I've shown a 3x3 electrical hazard risk assessment matrix example. There'd be a separate risk register table. You do work task-based risk assessments. You might have work task hazard pairs, because one work task could have shock and or arc flash, and then you implement a risk assessment, define risk control methods. So do you have in your electrical safety program a defined electrical hazard risk assessment matrix and related risk register table? So let's see what the answer comes back. So 43% say they do, 57% say they don't. So what we're seeing already is, again, an unraveling of a story that you right now do not have a compliant electrical safety program. So based on what I'm presenting, and again, in the time frame I have, I wish I could have more time, I'm trying to help you identify where you might have gaps, right? So quick gap analysis through this webinar. I encourage you to do offline a more formal internal electrical safety audit. So why do you need a compliant electrical safety program? Just to wrap up some bullet points. We want to save lives. We want to promote safety culture and behavior improvements in electrical safety and management of arc flash and shock hazards. We want to ensure your company eliminates exposure to these two hazards or reduces risk to as low as reasonably practicable. A safer, smarter, and more productive workplace. Good safety is good business. The right thing to do, save money, control budgets with a compliant electrical safety program. This one element is very important. And I think, my experience in the last 10 years is that companies have not been able to effectively budget training and studies and buying arc flash and shock PP. And if you have a compliant electrical safety program, that will be another benefit. At the bottom, legally compliant and defendable due diligence, right? So that is another reason why you need a compliant electrical safety program. So more information about why. You send your workers, your qualified electrical workers and your task qualified workers on arc flash and shock training. And really they come back to the workplace without a program in place to start out with, let alone a program that may not be compliant. It may not provide appropriate direction and requirements for the training to be applied. We need these workers to come back and apply the training against some requirements. In the training, they would have been told some of those requirements, but that's just a training course and knowledge transfer. They have to come back, and then the employer needs to have a management system, and that management system has to be compliant so that it captures all of the training and getting the value out of that training. Again, what you'll receive is enhanced productivity, when you establish an electrical safety culture based on workers' confidence, certainty, and electrical safety competence at its core. So moving the qualification, arc flash and shock training to electrical safety competency, you really only can accomplish that if you have an electrical safety program that the training is applied against. As well, a compliant electrical safety program has to address all worker roles. So at the bottom, we've got to make sure non-electrical workers on your work site are also included in the program. So I find that in some cases, when I've looked at electrical safety programs, it's only about the electrical workers. It needs to be an all-worker program. Qualified electrical workers, task qualified, operations staff, other specific non-electrical workers that will be exposed to shock when they use portable cord and plug connected electrical equipment and extension cords and need to understand when they need a GFCI. So just a wrap up on the incident statistics, right? So an electrical incident, if you ever have one, and there was in the poll question, unfortunately, with everybody that's attending, you identified that you're having incidents. So if they ever occur, injury or death is what the outcome will be, right? And heaven forbid if it's a fatality. It has a negative impact on worker productivity, everyone at the work site if it's a fatality. It leads to uncertainty and lack of confidence of the workers going forward. You'll have regulatory oversight, again, depending on the severity of the injury. If it's a fatality, it's basically a crime scene, right? You will not only have the OHS regulator there, but you'll have the police in attendance. Negative impact on company reputation, damage to electrical equipment. If it's an arc flash, you're going to have damage. That's going to result in downtime, minimal or significant. It would be determined by the severity of the arcing fault in the arc flash. And then you'll have associated electrical equipment repair costs, and then the legal costs. So you don't want to have an incident. This is some of the negative impact, first on your workers, with heaven forbid a severe injury leading to a fatality, but the other issues. So your electrical safety program is going to be used to make sure that we drive down the likelihood of ever having an electrical incident, and then you won't have to deal with these unfortunate outcomes of that incident. The role of 70E and Z462. So they are industry standards. They're well established. The US, it's been around since 1979, and Canada since 2009. For those of you online that are utilities, we have some separate standards. We have the National Electrical Safety Code in the US, and in Canada we have CAN ULC S801. So 70E and Z462 utilities are exempted from the scope being applied to them, but I do know that utilities do reference 70E and Z462 related to some of their businesses, but there are separate standards. Again, they're not adopted into law. They're industry voluntary standards. My opinion would be the regulators are going to expect you to use those standards even if they have not adopted them into law. And Z462 and 70 are very detailed and comprehensive and prescriptive because they're standards. What I find out there is companies that have implemented controls, specifically training. Arc flash and shock training is not a management system. It has nothing to do with a management system. It's knowledge transfer. The incident energy analysis studies do not dictate policies and practices. Employers need to control workplace application of the training and define and document your own policies, practice, and procedural requirements. And we can use 7E and Z462 to do that. As far as the electrical safety program requirement, both of these standards, they're technically harmonized currently, right? So Chapter 1, Article 110.5, Electrical Safety Program, and CSA Z462 Clause 416, they provide mandatory requirements that you shall have an electrical safety program, and that program can be developed independently and or in combination and combined with your overall safety management system. I recommend the electrical safety program as a standalone document, but it works underneath your overall safety management system. All right, your employer shall implement and document an overall electrical safety program that directs activity appropriate to the risk associated with the electrical hazards. The electrical safety program shall be implemented as part of the employer's overall occupational health and safety management system when one exists. So as I said earlier, 70E just published in September its 12th edition, and Z462, its 5th edition, will publish on January 2021. There is, again, changes to both of these standards, a lot of reorganizational changes. 70E specifically now has this amazing content on capacitors and electrical hazards. And Z462, we've actually updated the arc flash PP category tables, having the luxury of having the new IEEE 1584 2018 edition published while we were still updating the document. So they're evolving. They're industry accepted best practices. They're not formally adopted into OHS or OHS regulations. The OSHA inspectors have been trained to 70E in the US historically. And the language in OSHA, you can just almost directly link it to 70E language. In Canada, the OHS regulator has guidelines. And in some of the provinces, they do advise the regulator that they may want to look at Z462, but it uses the word may, not shall, so it's not adopted into law. But in Canada, the OHS regulator provincially and or federally would be aware of Z462, in my opinion, would use it in an investigation. So the clauses within, or the article or clauses within 70 and Z462 mandatory program, they provide guidance on the content within the documents, and I'll go through that. There's a mandatory risk assessment procedure, which I mentioned, and I think a lot of training doesn't effectively cover that, and I think it's missed, which a lot of you indicated you don't have a formal electrical hazard risk assessment matrix or an electrical specific work task risk register table. So, and then there's a job safety planning mandatory requirement. One thing I didn't mention yet with due diligence is document, document, document. If it's not documented, it's vapor, it doesn't exist. So the job safety planning requirement, I think that's a huge gap as well. I don't think employers have a document that's consistent with like a field level hazard assessment type document, but specific to arc flash and shock hazards. So this is a mandatory requirement that your electrical safety program has a documented job safety plan. And I think that's another gap area. 70E and Z462 point back to ANSI Z10 and CSA Z45001, which I mentioned earlier. So if you need help with what should be in your electrical safety program, go to these standards. So under the general requirements of 70E and Z462, which relates to your electrical safety program, the priority of your program should be elimination and then managing energized electrical work after that. You need a policy that defines that in your electrical safety program. There's this employer and employee obligations similar to the OHS regulations, and then the electrically safe work condition, energized work justification, and the normal operating condition is an important element of the risk assessment. And the normal operating condition has been moved forward into the electrical safety program requirement under the risk assessment procedure in the 2021 editions, and you'll see it in both of these documents. It more appropriately should be with the risk assessment procedure, not buried with the energized electrical work permit requirement. So the specific direction provided is this electrical safety program should be part of your overall safety management system. And now we're rolling up some of the information I already presented. You need to address that you have safe installations. Condition of maintenance, which I didn't and have not focused some time on in this webinar. That's another discussion point. But part of your risk assessment and normal operating conditions is condition of maintenance. Your program has to address that at a high level. Your electrical safety program is not an electrical equipment maintenance program. Do not make it an electrical equipment maintenance program. That's a separate requirement. You need awareness and self-discipline, principles, controls, procedures. The risk assessment procedure is very explicit in 70E and Z462 that your electrical safety program has to have a comprehensive, detailed risk assessment procedure. It's a job risk assessment. Underneath the job, you have individual work task risk assessments completed, and we determine a residual risk level for the job based on the work task risk assessments. And then you define the hierarchy of risk control methods. Again, but that needs to be in your electrical safety program. If you do not have adequate content in your electrical safety program related to the risk assessment procedure, you do not have a compliant electrical safety program. And the hierarchy of risk control methods, there's 6 of them mentioned in 70 and Z462. So just briefly, the risk assessment procedure is the worker exposed? There's 3 real steps to risk assessment. Identify the hazards. Are they exposed related to discrete work tasks? If we couldn't establish an electrically safe work condition, they will be. Do we need an energized electrical work permit? What's the potential of potential injury or damage to health and life of occurrence? We're evaluating that. Then we want to apply the risk control methods. And in 70 and Z462, the individual arc flash risk assessment and shock risk assessment define additional protective measures, which is using boundaries to set rules and policy, and then defining the arc flash and shock PPE. And then we monitor performance of those risk control methods. So this is in alignment with some of the information I've already presented, but this is what would be expected to ensure your electrical safety program is compliant. The electrical safety program also needs to deal with human performance related to your risk assessment. The job safety planning and job briefing, again, needs to be documented. Incident investigation needs to be addressed by your program. Electrically safe work condition policy should be there. Lockout tagout program, separate program, but your electrical safety program draws on that separate program with respect to establishing an electrically safe work condition. You have to audit. 70 and Z462 say audit your program, audit the field practices, audit the lockout program. They address training requirements and define a qualified person. As far as human performance, a worker's ability to manage factors that may interfere with the effectiveness of risk controls. A worker's ability to manage factors that may interfere with the effectiveness of risk controls. And there's a list on the right-hand side: workplace culture, mental health issues, concerns, distractions, information overload, training and competency, errors, mistakes, and lapses, complacency, time pressure, and violations. So this is really where the supervisor works with the workers in real time to manage human performance in real time and deficiencies that can lead to increasing the like of occurrence. So your risk assessment procedure should have considered human performance, and then separately your company will have to have in place, obviously, the HR policies to support ensuring you manage human performance, and the supervisor has the tools they need. So why you need a compliant electrical safety program? Why prioritize electrical safety? You want your team, your employees, your contractors, and stakeholders to be truly protected. It's the right thing to do. Zero harm performance target, right? There is no zero residual risk, but the target would be, we want to have that as our goal. When people feel safe, they're more productive. When productivity increases, you create scalable efficiencies, confidence in your workers. What I'm finding right now is there's lots of myths and misinformation out there about arc flash, and it's leading to lack of confidence in electrical workers and other task qualified workers. That's not good, because that drives up the like of occurrence of human performance dropping down and error, and then the incident occurring. We need to deal with these myths and misinformation, and through a compliant electrical safety program, the employer controls those myths and misinformation that are occurring due to training and issued arc flash hazard incident analysis study reports, or YouTube videos as an example, and you know, a misinterpretation of the information that's presented. So we want the electrical safety program to contribute to confidence of the worker, that they can work energized and that they will be safe. The risk will be managed. Many of you said you've had an incident. So if your company's experienced an incident, you want to ensure that you can do everything to prevent future occurrence. So through the electrical safety program and a compliant electrical safety program, we hopefully can manage going forward having any incidents, or lowering the likelihood, the probability of those incidents to as low as reasonably practical again. You'll have financial benefits. You'll have lower workers' compensation premiums because you won't have those injuries and have fatalities. Reduce your regulatory risks, meaning safeguarding your company's reputation. So a compliant electrical safety program with respect to arc flash and shock hazards, if you ever have an incident, it can impact your company's reputation, and ultimately, depending on the incident being a fatality, the value of your company and even your license to operate your company. So poll question number 7. Again, a lot of information in a short time frame. I've been moving quite quick so far. Again, we'll open up some questions here. Was this webinar of value, and did you learn something you did not know or consider? Again, I present a lot of information in a short time frame, and I know it's tough to absorb it all, but I'm hoping that after the webinar, you can review this offline, and you will come out of this with information you can use to gauge the compliance of your electrical safety program. So quick responses to this one. 99% yes. So there would have been something in the last 45 minutes or so that I presented for everyone attending, again, with respect to, if you don't have an electrical safety program, what do I need to do to get one and make it compliant? And for those of you that do have a program, very quickly, what are some of the gaps that you may have? So I'm going to open up the questions, and I'm just going to great.
So Terry, are you there? Can you hear me?
Yes, Vanu. I've just lost the
So,
PowerPoint.
is there a regulation related? Is there a specific requirement for Europe related to arc flash?
Yes, there is. So, and I'm not as familiar with what's going on in Europe as I would like to be. There's other individuals that are. So in the UK, they're working on specific energized work legislation. They do have documentation in place. The remainder of Europe, I'm not as certain. Again, I just haven't had the time and exposure in that area. So yes, and then globally, Australia, New Zealand, other countries, NFPA 70 is being used as an applicable industry standard in those jurisdictions, right? So yes, there is an evolution of requirements in legislation, indoor electrical energized work practice standards happening across the globe. It's an evolution in the last decade, I'll say.
So the next question is the comp premium cost comment documented? If so, where can I find this info? You mentioned about the comp
so
premium cost.
For workers' compensation, you've got to go to your particular government agency that manages that. And again, in Canada, the certificate of recognition process, it's a formal process that the government runs. And if you get your management system audited, then there'll be forms that you would submit to the government to get the workers' compensation premium reductions. Be similar in the US, so look to the jurisdiction and the potential benefit of getting any specific immediate workers' compensation premium reductions.
So the next one is the duty clauses reflect each individual industrial sectors or they're independent?
So if I interpret that one correctly, and I just quoted general duty clauses, any employer under the regulations will have an obligation to identify all workplace hazards and then to eliminate exposure or implement risk control methods to reduce risk. So it's explicit that you will do something as the employer for all workplace hazards, but then more explicitly, there will be content with respect to specific requirements, as I mentioned, for electrical safety and OSHA or the OHS regulations. Then they'll more explicitly outline what you need to do as far as elimination, and if you can't eliminate, the expectations of what they want you to implement as the controls.
So the next question is 70E 2021 out and in effect now or sometime in 2021?
NFPA 70 published in September, and it supersedes the 2018 edition. You can download a PDF from NFPA's website after this webinar. So when a new standard is published, it supersedes the existing standard. So September 2021, 70 published, Z462 will be the end of January. So again, the 2018 edition of 70 no longer applies. You have to have the 2021 edition. Again, your electrical safety program, you have to audit it against the new requirements or the changes in the applicable standard that we're basing the requirements, the policies, practices, and procedural requirements of the electrical safety program against.
Thanks, Terry. So the next one is, can you go over where a risk assessment matrix is a requirement in 70E?
So if you
specific section where 70 calls out risk assessment matrix.
Right. So if you go to Article 110.5 and or Clause 4.16, it will point you to Annex F in both of the standards. Annex F gives you more information on the risk assessment procedure. There's a flow chart of how to implement a risk assessment, and there's an example 2x2 risk assessment matrix. Now that risk assessment matrix example is too granular. You need to expand it, excuse me, to more rows, and that's where the 3x3 that I showed you briefly is more appropriately, your capability of using it is more appropriate when you go to 3x3. And then there's risk assessment standards out there as well. So there's ISO risk assessment standards. In Canada, there's CSA Z1002, which is based on other risk assessment standards that give you guidance on how to develop a risk assessment matrix custom for your company. So if you go online and you Google risk assessment, you'll see examples under images of multiple risk assessment matrices as well. 3x3, 2x2, 4x4, 5x5. The complexity is dependent on what you establish in your organization. But the 2x2 in Annex F is not, it's just an example. And 2x2, it's going to drive you to make inappropriate decisions. So I recommend at least a 3x3. And you're designing the potential severity of injury, potential injury or damage to health severity levels. I had S1 to S3, and that allowed me to have basically a no injury or a minimal injury to repairable injury to a fatality. And so that's why it has 3 levels of severity. And then I had 3 levels of likelihood of occurrence, right? So again, your company needs to define a matrix, or one can be defined for you, and then you can apply.
Thanks, Terry. Can you use due diligence to justify energized electrical work for tasks that may not have additional or greater hazard?
Can you read that again, Banu?
Can you use the due diligence to justify the energized electrical work for tasks that may not have additional or greater hazard?
So that gets us into the energized electrical work permit concept and the justification for energized work. So currently the 70 lists justification, and so does Z462, as increased risk or hazard or infeasibility due to equipment design or operational limitations. So when I work with companies on defining the permit, really right now it's confused. So this question tends to lead me down that path. Some companies believe you need an energized electrical work permit for every energized electrical work task. That's not true. And there's exemptions that are listed based on, again, the justification of infeasibility, equipment design. So you have to take what 70 and Z462 offer you as justification. I encourage that you actually, in your electrical safety program, document additional exemptions. The permit, in my opinion, is valuable for trying to eliminate repair and alteration in an energized state, right? So that's when and if you do have justified work, you can do the repair and alteration. So equipment design and operational limitations, again, subjective interpretation, due diligence-based discussion here for sure. So operational limitations. Some processes do not like to be shut down. If you shut them down, you can have increased risk or hazard to the equipment or to the workers with respect to that equipment. So you need to really understand how you use those words of justification and how you would deploy the energized electrical work permit when it is energized repair and alteration. Equipment limitations, to me, is quite clear. How do we isolate electrical equipment that has a power circuit breaker if we don't rack out the power circuit breaker? The equipment's designed to have the power circuit breaker racked out with the line side energized and the load side obviously de-energized. So we don't need a permit to rack in or out a power circuit breaker due to equipment design. The same thing with installing temporary protected grounds. How do we establish an electrically safe work condition if we don't first isolate, then for high voltage install grounds? So we don't need a permit for that because it's equipment design related, right? So those, by the way, are isolation work tasks. They're not maintenance tasks, they're isolation, racking in or out, or installing grounds. So everything needs to go back to your electrical safety program. Do not have the opinion of one person in your organization that says, well, this is what we're going to do. No. So take the information that you have, your electrical safety committee sits down, you define what you're going to do and put it in your electrical safety program under your energized electrical work permit process policy. So I hope that answered the question.
Thanks, Terry. So the next one is, do you foresee an increase on arc flash accidents recording as knowledge about the hazards gets better defined and incorporated into OHS programs?
That's a good question, because I'm going to provide 2 answers. I think that for the last 13 years that I've been involved, where I didn't even know what an arcing fault and arc flash was, obviously my personal contribution to my employer at the time increased and we put focus on it. So I think that we're going to see a reduction in any potential abnormal arcing faults that lead to arc flashes due to worker interaction or lack of maintenance without interaction. But ultimately, what I'm concerned about is an increase, right? Because what I'm seeing is, with the myths and misinformation out there on arc flash, qualified electrical workers and other task qualified workers that we need to do energized electrical work are not confident anymore. They're concerned that they're going to lose their job. They're going to lose their certification, their ticket to make an income, because they're going to get fired for working energized. So that's wrong and false, by the way. So I think we might see a trend upwards if the confidence of the worker is declining because of the myths and misinformation about arc flash. So I think it's been good and positive, but what I'm seeing in the last 5 years is a lot of myths and misinformation leading to workers not being confident. And if they're not confident, the like of occurrence of them making an error goes up. So I hope we don't see that trend, but we've got to deal with, and through your electrical safety program is how you can deal with this, the myths and misinformation out there about arcing fault probability and when a worker is exposed to arc flash and what's being communicated to your workers in training or even by the regulator with respect to arc flash. So again, two answers there. And I hope we don't see an increase in arcing faults and arc flash exposures because of this uncertainty and the lack of confidence of the worker. Again, I hope again that you manage that within your company and deal with these myths and misinformation through your compliant electrical safety program.
All right, we'll take one last question, Terry. We have seen data centers go to A to B dual feed end equipment that allows us to de-energize the PDU to perform maintenance. Why can't hospitals go to a similar system? They are our worst customers about de-energizing equipment.
So I think the question was data centers and changing the power system design to allow effective isolation. And then the second part was, why can't hospitals do that? And
do that.
Yeah. Well, I think hospitals could do that. And but the problem is that their existing power systems may not allow them to do that. Like, you know, they've got obviously legal requirements for uptime, reliability, and standby generation, right? So, you know, a loss of utility, they still have to have power to source their systems, but then in turn, well, Terry, they're just on, you know, emergency power generation at that time. So the power system designs, again, historically probably haven't effectively allowed segregation, right? So hospitals have a lot of challenges, and we need those challenges, again, to continue to be managed by the electrical maintenance departments within those organizations. And that is where we may see energized repair and alteration with justification. But then there's a double-edged sword to that too, because you'll hear people say, well, Terry, if hospitals, they do energized repair and alteration, what happens if they have a fault? Then the power goes down anyways, right? So that is the decision that the employer, again, the authority for those hospitals within the state or province or territory here in Canada, has to manage, again, energized work and the risk of again, having the power go down. So the first priority is, can we turn the power off and do the repair and alteration? Well, we can't, because that power services, you know, this portion of the hospital. Is there any time where we can turn the power off, you know, to minimize the impact? So this would be the evaluation that should be happening in hospitals. You know, is there a time when the impact is minimized, and then we still, you know, do energized repair and alteration? So again, this is not an easy discussion, but I'm sort of outlining for hospitals that's sort of historically how hospitals have managed doing maintenance on their power systems. Because the other thing too is you have to shut down the power system to do maintenance on it. So there's challenges in hospitals that are unique. Data centers, it's also a similar discussion, right? You know, we rely on the data for 911 calling. Obviously, you know, everything else we do these days is heavily dependent on the internet and the cell phone net and everything else. So that's another discussion, because that one has the loss of revenue associated with it. But, you know, I would almost say that the telecom and the internet are like essential services these days. So is there increased risk or hazard if we lose the internet? And right now, given what's going on, and you know, the internet is so critical to communication. So these are, again, in your electrical safety program, where you might have to document unique requirements underneath your energized electrical work permit process policy. So there is no definitive yes or no in some of the industries out there with respect to energized repair and alteration. Ultimately, it comes down to risk at the end of the day as well. So you do the risk assessment procedure, you're going to do that energized repair and alteration. The priority is going to be, is the worker going to be, you know, safe, right? Are we managing the potential severity of injury or damage to health to the worker at that point? The like of occurrence has the impact on the reliability. So And then for hospitals, if the power goes out, what's the impact on the patients, right? So there's a more complicated discussion there with respect to, again, the topic of energized repair and alteration, harm to the primary worker, harm to the patients, and how to recover from that. And again, hospitals right now, that said, they have and should have emergency response plans for, again, utility loss and then even generation loss, right? So ultimately, at the end of the day, the maintenance department will have in place through the operating side of the hospital, worst case scenarios. They never want to go there and test it, but it would be part of what's established related to emergency response. Again, I could talk for quite a bit of time, on any one of these questions. If you know me, Terry will go on. So Banu, I'm going to stop, and if there is any other questions, Banu, I'm more than glad to continue to chat about them. But I think we also just cut off the webinar as far as the length of what we're recording and providing to everybody out there. So Banu, I think we should close off the webinar, I guess. And if there is questions, attendees can reach out to us.
Sure. Thank you again, Terry. Thanks again, everyone, for joining our webinar this morning. And as you can see, there is this Grace Technologies Expert Network brochure that's on the handout section. Please go through that and definitely reach out to us if you want us to help you out with your electrical safety program. And also on the chat window, I posted a SurveyMonkey link with which you can take electrical safety program self-assessment, which is like a weighted score with which you can evaluate and assess where you stand given your current program. And definitely I'll be more than happy to help you out in developing electrical safety program if you don't have one, or just working with you in refining your existing program if you already have one. So yeah, please go and take out that exit survey and reach out to us. We can definitely help you out in your electrical safety endeavors. Thank you so much, Terry, and thank you everyone for your time.
Hey, thanks, Banu. Thanks, Grace. Thank you everybody for attending. Have a good day and take care out there. Bye.